welcome to the 8.03 A2 notes on trig expressions. And also some intro to identities and complementary function. Complementary functions. All right, so what we're going to do is start by simplifying trig expressions. So a couple hints to start these off with. Number one, always try to rewrite as much as you can in terms of sine and cosine. Much as you can using sine and cosine. Another hint is looking to substitute your Pythagorean identity. Substitute, which is sine squared plus cosine squared equals 1. So that's sine, and again, this is the same thing as saying sine of x squared plus cosine of x squared equals 1. So those are your two big hints that should help you as we do these. All right, so let's take a look at the first one. So all of these, the directions are to simplify. So we're not solving for x or anything like that. We are just simplifying. So this is cosecant of theta times tangent of theta times cosine of theta. So what we want to do is try to simplify this. So to do that, we want to see, can we rewrite any of these things in terms of sine and cosine? And here we have cosecant, and we should have memorized that cosecant is the reciprocal of sine. So I can rewrite that as 1 over sine theta. Then I have tangent of theta. So some students get a little confused here because they try to use cotangent of theta when they see tan or vice versa. But really, we want to try to get everything in terms of sine and cosine so that we can reduce. So tangent is the same as sine theta over cosine theta, and that's another one of those things you need to memorize. So that's really important to have here. And then cosine of theta is already in terms of cosine of theta, so I'm just going to leave it. And since everything else is a fraction, I'm going to put it over 1. All right, so now I look here and I'm multiplying, not cross multiplying because there's no equal sign. We're just multiplying 3 fractions. So we actually can cross reduce here. So I see a sine theta in the bottom and a sine theta in the top. So those would divide out to give me 1. Sine theta divided by sine theta is 1. I also have a cosine theta in the top and the bottom, also reduced to a 1. 1 times 1 times 1 is 1. And in the bottom, all those canceled out. So we're just left with 1. So our final answer is 1, which is pretty crazy that that whole thing simplifies down to just 1. And a lot of these are pretty cool. So it's number 2, cosine squared theta times secant theta times cosecant of theta. So first thing I'd like you to do is pause your video and see if you can rewrite all of these in terms of sine and cosine. All right, so the first one is already cosine, so I'm going to leave it, times secant. I can rewrite that as 1 over cosine. And cosecant theta, I can rewrite that as 1 over sine theta. So now I'm going to put this one over 1 since everything else is already a fraction. And now I'm going to try and cross reduce. So I see a cosine squared up here in the numerator and a cosine theta in the denominator. So if I have 2 in the numerator and 1 in the denominator, I still have 1 left in the numerator. It's like saying x squared over x would simplify to just an x in the numerator. And there's really nothing else I can simplify here. So I'm going to now multiply straight across the top. So cosine times 1 gives me cosine theta. And straight across the bottom. So 1 times sine theta is sine theta. We want to try to rewrite these as a single trig function. So now what is cosine theta over sine theta? Well, we know that tan theta is sine over cosine. So cosine over sine is cotangent of theta. So to remember that, I like to say it's cotangent. Starts with CO, has cosine theta, which starts with CO, over sine theta, which, remember, tan theta is sine theta over cosine theta. So you're just flipping it. You're taking the reciprocal for cotangent. Cotangent's cosine over sine. So co is your cotangent. All right, and the next one. Sine squared x plus cosine squared x over cosine of x. So here, hopefully you notice that we've got our Pythagorean identity here, sine squared plus cosine squared. And we know that sine squared x plus cosine squared x is equal to 1. So I can take out that whole thing in the numerator right here, and I can replace that with what it's equal to, which is a 1. So that's 1 over cosine of x. And how can I rewrite 1 over cosine of x? Well, think about what is the reciprocal of cosine. 1 over cosine of x is equal to the secant of x. Okay. All right, number 4 is 2 sine theta cosine theta. This one should be hopefully a quick one, over sine theta. See what you can reduce and rewrite this one. So hopefully you notice here you can just cancel out those sines of theta, leaving you with 2 times cosine of theta, still a single trig function. Number 5. Tan theta over secant theta. All right, so pause your video here and rewrite everything in terms of sine and cosine. So tangent, we said, is sine theta over cosine theta, divided by secant theta is 1 over cosine of theta. C's and S's go together. Now we have fractions inside of a big fraction. So this is review from our rational expressions and equations unit. We have a complex fraction. So you have 2 ways of handling this. You can do keep, change, flip for this, or you can find your LCD. So our LCD here would be cosine of theta because that's our denominator of both fractions. And then I can multiply everything by my LCD over 1. In brackets if you don't have another color. And then I can cancel those out, so cosine theta. So now everything in the denominator is canceled out, leaving me with just sine theta over 1, or just sine of theta. Another option you could have done is your keep, change, flip. So sine theta over cosine theta, change division to multiplication, and then flip your 1 over cosine. So it's cosine theta over 1. And then you can cancel out your cosines, leaving you with sine theta. So 2 different ways of doing the same problem. Number 6 is cosine theta times secant theta minus cosine theta. So with a lot of these, as you get into harder ones, there are multiple ways of doing them. But let's start this one again with rewriting everything in terms of sine and cosine theta. So you could have also started by distributing. So now I rewrote secant as 1 over cosine. Remember, C's and S's go together. Those reciprocal trig functions are something you need to have memorized. All right, so now let's distribute our cosine theta in. So now I have cosine theta over 1. So cosine theta times 1 is cosine theta. over cosine theta, and you may have cross-reduced there and realized it was 1 a little earlier, minus cosine squared theta. So now cosine over cosine is 1 minus cosine squared theta. Okay, so I know that I have a Pythagorean identity. I'm going to write it out over here. Is sine squared theta plus cosine squared theta equals 1. Now, the question is, can I rearrange this Pythagorean identity so that it's the same as 1 minus cosine squared? So to do that, I would have to subtract cosine squared over. So now I have sine squared theta equals 1 minus cosine squared theta. So now I know 1 minus cosine squared theta is equal to sine squared. And if you had 1 minus sine squared theta, that would equal cosine squared theta. Another way of doing it is if you had solved for cosine squared theta, so you could have subtracted. I'll just show you up to this side here if this makes more sense. So you could have got cosine squared by itself by subtracting sine squared over to the right side, and then you could sub in 1 minus sine squared in for your cosine squared and distribute the negative. It's a little bit more work. So if you can recognize, as soon as you see cosine squared plus sine squared, recognize that it's equal to 1. If you see 1 minus cosine squared, that's going to give you sine squared, and 1 minus sine squared will give you cosine squared. And this 7. So this is just an or, a different way of solving that one. Number 7. Cosine squared theta over sine theta plus sine theta. So here, everything is already in terms of sine and cosine. So what can we do? Well, if I put this over 1, I want to combine them into one fraction. In order to add fractions together, I need a common denominator. Okay, so looking at your denominators, you have a sine theta and a 1. So what would be our least common denominator? Hopefully you're able to say that that would be sine theta. So in order to add these, remember there's no equal sign, so I need to multiply by what it needs over what it needs. So the first fraction already has a sine of theta, so it doesn't need anything. The second one does not have a sine of theta, so I'm going to rewrite the first fraction. And then the second fraction, I'm going to multiply by what it needs, which is sine theta in the denominator over what it needs. So I'm multiplying by a form of 1. So now I have cosine squared theta over sine theta for my first fraction. Now sine times sine will give me sine squared theta over sine theta. Once I have a common denominator, now I can combine the two fractions, and so you add the numerators, cosine squared theta plus sine squared theta, and keep your denominator. Oh, I love when this happens. So now I have cosine squared plus sine squared, and hopefully you recognize that again is your Pythagorean identity. And we know that cosine squared theta plus sine squared theta is equal to 1. So I can take out cosine squared plus sine squared and replace it with 1. So I have 1 over sine theta, which is equal to, hopefully you're saying cosecant theta. All right, so we left off getting cosecant theta. So now I want to show you a couple of ways to figure out 2 other Pythagorean identities that we have. So use algebra to show each of the following is true. So as you go on into other math courses too, we're going to use 3 different Pythagorean identities. So I'm going to give you a Pythagorean identity that we already know. So cosine squared theta plus sine squared theta equals 1. So that's the one we already know. And I want you to show that tan squared theta plus 1 equals secant squared theta. And this actually showed up on the regions before as well, just getting from one Pythagorean identity to the other. So when you're doing this, I like to look at the end first and say, okay, well, I have it equal to 1. And in this equation, I need it equal to a secant squared. So think to yourself, 1 divided by what gives me secant? And hopefully you're saying 1 divided by cosine. But I want it to give me secant squared, so I would have to divide by cosine squared theta. So I'm going to rewrite my given again. So cosine squared theta plus sine squared theta equals 1. And I want to divide, if I divide this last term by cosine squared theta, I have to divide every single one by cosine squared theta. You can't just take an equation and pick and choose what you want to divide something by. You have to divide every single term by the same thing. Now we're going to reduce. So cosine squared over cosine squared gives me 1. Sine over cosine is tangent, so sine squared over cosine squared is tangent squared. And then 1 over cosine is secant, so 1 over cosine squared is secant squared theta. And if we look at our show, it's the same thing. It's just using commutative property. We can use addition is commutative to rewrite it exactly the same. And we've showed that last one. Okay, so dividing everything by cosine squared in our Pythagorean identity gives us another Pythagorean identity, which is tan squared plus 1 equals secant squared. Let's do one more of these. So given, again, cosine squared plus sine squared equals 1. And I want you to show that 1 plus cotangent squared is equal to cosecant squared. So this time, again, go to the end. So this is equal to 1, and this one's equal to cosecant squared. So think to yourself, how would I get a 1 to become a cosecant squared? So the exact same process we just did, except you're not going to be dividing by cosine squared this time. Pause your video and see if you can get from this given to this show equation after. All right, so hopefully you said you were going to divide by sine squared here. So now if I divide the last one by sine squared, I have to divide them all by sine squared. So I start with my given, because I know that's already true. And I'm going to divide every single one of these by sine squared. And we'll reduce. So cosine over sine, that's your so cotangent. And since it's cosine squared and sine squared, it would be cotangent squared theta. Sine squared over sine squared just reduces to 1, and 1 over sine squared is cosecant squared theta. And again, you could use your commutative property of addition to switch the order. And it's the same as what we're trying to show. All right. The last thing we're going to talk about here are cofunctions. So that tells us that complementary angles of complementary functions are equal. So before we go on, what does it mean to be complementary angles? And you may have learned that little trick. You make the C and draw 1 down, you get 90. Complementary angles means they add to 90 degrees. I'm draw a picture of a right triangle. And I'm going to call this X and this Y. And here's your right angle right here. And this is going to be a 3, 4, 5 triangle, just so that you can understand what's going on here. So first of all, I want to look inside at your angles. So we know that in a triangle, these 3 angles have to add to 180 degrees. We know one of the angles is already 90. So 180 minus, well, let me show you this. X plus y plus 90 has to equal 180. So if I subtract both sides by 90, I know that x plus y has to equal 90. 180 minus 90 is 90. So these two angles right here, x and y, those are complementary, meaning they add to 90 degrees. If we know that our angles are complementary, so we have a right triangle, the two acute angles are always going to be complementary because we're in a right triangle, you're always having one angle that's 90 degrees. So now I want you to find the sine of x. So if I find the sine of x, we've got SOHCAHTOA, make sure you're spelling it correctly. Sine of x is opposite over hypotenuse, so that would be opposite is 4 over 5. And then find the cosine of angle y. So angle y is over here. Cosine is adjacent over hypotenuse, so that's going to be adjacent is 4 over 5. And notice you get the same thing because what's opposite from x is going to be adjacent to y. So that tells us that anytime you have these complementary functions, we know that the cosine of x will equal the sine of y and vice versa. We also know the sine of x will equal the cosine of y. And that's only if x plus y is equal to 90. So if you have a right triangle and those are your acute angles. So for your complementary functions, we have not only sine and cosine that match up together in this way. So sine and cosine, they're reciprocals of cosecant, and secant will also do that same thing. And then also tangent and cotangent. So anytime you see these set equal to each other, that tells us that their angles add to 90 degrees. So if set equal, the angles add to 90 degrees. They have to be complementary because they're going to be the other two acute angles in the right triangle. All right, so let's do a couple practice here. So find theta when sine theta equals cosine of 15 degrees. So once you see sine and cosine set equal to each other, and you guys should have done these in geometry with just sine and cosine already. So if we know sine and cosine are equal to each other, then we know their angles, theta and 15, have to add to 90 degrees. So theta plus 15 has to equal 90. Subtract your 15 from both sides, and we get theta will be 75 degrees. Okay, let's try another one. Cosine, a little harder, of 2x plus 25 degrees equals sine of 35 degrees. And find x. All right, so again, we see that they're set equal to each other, cosine and sine, which means their angles, so the 2x plus 25 and the 35 have to add to 90 degrees. So we take 2x plus 25 plus 35 and set them equal to 90 degrees. Pause your video, go ahead and solve. So we've got 2x plus 60. If we combine our like terms, 2x equals 30 by when we subtract 60, and you should have gotten x equals 15. Number 12, find x again. Sine of 2x plus 20 degrees equals cosine of 40 degrees. Pause your video, solve for x. So again, since sine and cosine are set equal, you should have had 2x plus 20 plus 40 equals 90. And again, your x should be 15, and I should see the work on your papers. Let's do another one. So let's switch it up. Instead of sine and cosine this time, let's take the secant of 60 degrees equals cosecant of x plus 10 degrees. So this time it's a little bit different because we don't have sine and cosine, we have secant and cosecant, but the same exact concept. So once you see them set equal to each other, if it helps, circle the angles, set them equal to 90, and solve for x. Go ahead, do that right now, pause your video. So again, you'd have 60 plus x plus 10 equals 90. So then you should have had 70 plus x equals 90, and x equals 20. And we'll do one more this time with tangent and cotangent. So the tangent of 4x plus 40 degrees equals the cotangent of 2x minus 10 degrees. Find the value of x. Pause your video and solve for x. All right, so again, tangent equal to cotangent. So then if it helps you, circle the angles. So angle, it's always tan of the angle, cotangent of the angle, sine of the angle. The angle is always attached to the trig function. And then you should have set up 4x plus 40 plus 2x minus 10, set that equal to 90. Solve for x, and in this one, x is equal to 10. And I should see the work on your paper for that one as well. All right, that is it for today. A lot of stuff that I think is really fun, but I know can be very challenging stuff, especially those trig identities that we did in the beginning, simplifying those. So sometimes you just have to really just dive in and try something. Trying something is better than just doing nothing. And a lot of times that something gets you somewhere else that allows you to figure out what you need to do. So really important that you just try. Again, try putting in sine and cosine, looking for your Pythagorean identities, things like that. All right, and have a great day. I hope to see you all soon, and pie out.